Hey everyone, and welcome to today's explainer. So if you're watching this, you probably already know exactly how to drag and drop those colorful blocks to, make a cat dance or a rocket fly across your screen. You have totally conquered block-based coding. But now, well, it's time to level up. Today, we're going to unlock some serious new coding powers by moving from block programming like Scratch to text-based coding. And we're going to use one of the absolute most popular languages in the entire world, Python. So grab your keyboards because things are about to get really fun. Okay, quick mission briefing. Here's our level map for the powers we're unlocking today. We'll decode how blocks translate to text, explore your new Python playground, learn how to ask users questions, sort our data, do some math, and finally, face the ultimate boss battle, becoming a bug hunter.
All right, section 1, from blocks to text.
Now, Python's interface is definitely going to look different than what you're used to. Instead of a bright stage and snapping colorful blocks together, it's mostly just text on a plain background. And yeah, I know, that might look a little intimidating at first glance, but I promise you, the logic is exactly the same. You're still just giving the computer step-by-step instructions. The only real difference is that now you're actually typing those instructions out yourself. And to do that typing, we get to learn a new magic word: syntax. Basically, think of syntax as the grammar rules for our computer. Just like you need a capital letter at the start of a sentence so your teacher understands your writing, you have to follow Python's syntax rules so the computer understands your code. If you misspell a command, well, the computer just simply won't know what you want it to do. Moving on to section 2, 2 ways to code. So Python has this special program called IDLE, which stands for Integrated Development and Learning Environment, and it actually gives us 2 completely different ways to write our code. First up is interactive mode, which uses the Python shell. You can think of this like a super-powered calculator. You type in one command, hit enter, and boom, you get an instant answer. But just like a normal calculator, it doesn't save your work. Then we have script mode. Now, script mode is more like writing a book. You can type out lines and lines of code, save the whole thing in a file, and then run your entire story from start to finish whenever you want. Because of that, knowing how to save your hard work in script mode is absolutely crucial so you never lose it. And it's really just 5 quick steps. You go up to the menu, click File, then New File to get a blank page. You type out your awesome code, then you click Save As and name it, and remember, Python files always end in .py. Finally, you click Run and Run Module, or honestly just hit F5 on your keyboard, and you get to watch your program come to life. Section 3, Asking Questions with Code. Okay, let's look at a direct translation from blocks to text. You've probably used the Scratch ask and wait block 100 times to ask a player for their name, right? Well, in Python, we use the exact same concept, but it's called the input function. You just type the word input and then put your question inside quotes and brackets. When you do that, Python prints your question on the screen and literally just waits for the user to type their answer. It is the exact same superpower, just typed out. But wait, when the user types in their answer, where does it actually go? We need a place to keep it safe. And that is where a variable comes in. A variable is simply a named location in the computer's memory that stores data. Think of it like a storage box with a label slapped on it. If we label our box player name, we can safely store whatever the user types right inside that box. Then, later in our game, if we want to say hello to the player, we just open up that player name box and grab their name. Simple as that. Section 4, Knowing your data types. So, we have our storage boxes, but we can't just throw random stuff inside them without telling the computer what it is. Computers need to know exactly what type of data they're dealing with so they can handle it properly, kind of like a sorting hat. In Python, there are 3 main types we really need to know right now. First are strings. A string is just text, letters, symbols, even a mix of everything, like the words hello world or a secret password. Next, we have integers, which are any whole numbers, like 24 or even -10. And finally, we have real numbers, which Python calls floats. These are your numbers with decimal points, like 6.98. But for right now, I really want to focus on the integer. Remember, an integer is any whole number. If we want our program to count points or calculate distance or do literally any sort of math, we have to make absolutely sure our numbers are stored as integers. This specific data type is the key to unlocking our math powers. Which brings us to section 5, Doing the Math. Now, Python is a total mathematical genius, but I gotta give you a massive warning about what happens when you forget to sort your data properly. Imagine you ask a user for a number, and they type 50. Then you ask for another, and they type 100. If you try to add those together without telling Python their numbers, it might just spit out 50,100. Crazy, right? That's because the input function automatically stores answers as string text. It thinks you just want to glue the word 50 and the word 100 together. So to actually do math, you have to use a spell called casting. You wrap your input in the command int, which stands for integer. That magically transforms the text 50 into the actual number 50, letting the computer know it's time for math. And once you cast your variables as integers, your math powers are pretty much limitless. Python uses basic arithmetic operators. The plus and minus signs are exactly what you're used to. For division, we use the /. And for multiplication, instead of an X, we use the star symbol, the asterisk. Oh, and don't forget, Python is super smart, meaning it always follows the BIDMAS rules, calculating brackets first, then indices, division, multiplication, addition, and finally subtraction.
Section 6. Be a bug hunter.
Okay, take a deep breath. We have officially reached the final boss battle of today's explainer. And I'm going to let you in on a little secret that even professional coders know. Everybody makes mistakes. Literally everyone. When your code doesn't run or it throws some giant red error message at you, it does not mean you're bad at coding. It just means your code has a bug. Debugging is simply the process of finding and removing those errors. When you debug, you're basically putting on a trench coat and becoming a code detective. You hunt down the clues and solve the mystery. Let's actually test out your detective skills right now. One of the absolute most common errors in all of Python happens with print statements. People will type out their command, but at the very end, they forget the closing bracket. The syntax is completely broken. It's like the computer is waiting for you to close a door, but you just left it wide open. Luckily, it is a super easy fix. You just type that closing bracket, and suddenly your code is working perfectly again. And here's another incredibly common bug you really need to watch out for. Python is completely case sensitive. That means it treats a capital letter and a lowercase letter as two entirely different things. For example, if you try to type the print command but you accidentally use a capital P, Python's going to be super confused. It doesn't know what print with a capital P is. It'll just throw a name error right back at you. Built-in commands like print and input always have to be typed in lowercase letters. So keep your eyes peeled for those pesky capital letters when you're hunting for bugs. And with that, you've made it through the briefing. You now know how to translate your block skills to text, save your scripts, capture user input and variables, cast integers, do some math, and hunt down bugs like a pro. So the only question left is, what amazing programs are you going to build with your brand new Python powers? Will it be a calculator, a wild text-based adventure game, or maybe a digital sweet shop? Open up IDE, embrace the bugs, and start typing out your very first adventure. Thanks so much for joining me on this explainer, and happy coding.